We have a sector of a circle labelled with radius 6 and arc length 10. The thing that's missing is the angle, which we don't know, so I'm going to call it theta, and we're asked for the area. Well, first thing is to sort out the arc length. Sometimes it's called L, by the way, but I'm just going to go straight. I'm not going to write a formula down. I'm just going to sort of use my intuition. So the arc length, well, the circumference of a circle is equal to 2 pi r. So it's going to be 2 pi times 6, or equivalently pi d, which we double the radius to give 12, so then 12 pi. But I don't have a full circle. I actually have a fraction of a circle. I have theta over 360 degrees. So that is my formula in terms of theta. What can I do now? Well, I think I'd be very tempted to instead of timesing through by 360, my temptation is to first of all kind of cancel things down. So if I'm timesing by 6 and dividing by 360, I can partially cancel this to divide by 60 instead. And if I'm timesing by 2 and dividing by 60, it's the same as dividing by 30. So I'm going to have that I can times by 30 now, so 300 is equal to theta pi, or pi theta. Therefore, theta is going to be 300 divided by pi. That's going to be useful for then the area, because the area is going to be my angle, 300 divided by pi, divided by 360. Again, I'm writing the fraction first now, but it's the same idea as over here. And then I'm timesing by pi r squared, so it's going to be pi times 6 squared. The first thing to say is if I'm dividing by pi and timesing by pi, they're going to cancel. And then I'll be left with, well, I'm going to cancel that 0 with that 0. So it's going to give me 30 times 36 over 36. I don't even need to do the calculation. They're going to cancel out. My final answer is going to be 30. Just want to give an alternative method to this as an add-on. And it is actually nicer. I didn't think to do it myself when I did it, but I looked at the solutions and it's really nice. And it is to notice that basically the area of the sector, if I was to divide it by the area of the circle, then I'd be left with sort of the fraction that I actually have of the circle. But that must equal the arc length. That's how much I have of the circle as a perimeter, divided by the perimeter of the circle, so the circumference. So we can write that equation down. And therefore the area of the sector divided by the area of the circle, which is going to be pi r squared, so pi times 6 squared, so 36 pi. And that will equal the arc length, which is 10, divided by the circumference, which is 2 pi r, or 12 pi. The pi's cancel. The 10 over 12 will just become 5 over 6. And so the area of the sector will be 5 over 6 times 36. 6 is into 36 goes 6, so it's 5 times 6, and it's 30. Really nice approach, which is much shorter and didn't involve all these fractions.